Let's talk about the first order differential equations, in specific, exact differential equations. There is some cases where you don't have neither a linear differential equation nor a separable one. In that case, you want to try to look into that equation and confirm that equation is exact, or try to make it exact to be able to solve it. So an exact differential equation will be in the following form: mu of x and y as a function dx plus nu of x and y dy equals 0. Now, mu is the factor of dx and nu is the factor of dy, where mu equal partial phi over partial x and nu equal partial phi over partial y. Now, in order for equation number 1 to be exact, then mu needs mu as a function of y should equal to nu as a function of x. So we can say if partial mu over partial y equal partial nu over partial x, then we have an exact equation. So that's how you will verify when you have a certain equation that's not linear nor separable, and you want to testify if it's an exact equation, an exact differential equation from the first order. Then you want to testify if partial mu over partial y equals partial nu over partial x, then this equation is exact and we can proceed with the solution. As we will learn later, if it's not exact, there's a way to make it exact. But in today's lesson, we will try to learn how to solve a differential equation using the exact method. Now you confirmed that your equation is exact. The next step, you can say partial phi over partial x equal mu. Then in this case, mu equal certain term, then you will integrate that term as we will learn with the coming example. So you will integrate, and that will give you phi equal the integrated term plus the integration factor g of x, and the partial phi over partial y equals nu, and from that we can find the resulting term after the differentiation of phi over here. It will give you that differentiated term plus g prime of y. Now we know from that specific equation g prime of y equal certain term, and integrating that, so integrating that will give you the value of g of y equaling certain term. So in that case, you can compensate g of y that is missing from the phi equation. Let's take an example to clarify the concepts we discussed about the exact equations. Assume we have this problem: 2x multiplied by y cubed minus 3y dx minus 3x minus 3x squared multiplied by y squared plus 6y dy equals 0. Now first we want to identify the functions mu and nu. In this case, mu is the function related to dx, that's mu, and nu is the function related to dy. Okay, then now to be more clear, we can write on the side that mu equals 2x multiplied by y cubed minus 3y, and nu equals, watch out for the integrated value over here, nu equal minus 3x plus 3x squared y squared minus 6y. First thing we want to do, we want to confirm, is this equation exact or not? Which means we want to know, does mu equal, does partial mu over partial y equals partial nu over partial x? So partial mu over partial y, does it equal partial nu over partial x? Okay, then let's differentiate mu with respect to y over here and differentiate nu with respect to x. If we do that, then we will get 6x y squared, that's the differentiation for the term over here, minus 3 equals minus 3 plus 6x y squared. As we can see, this term is the differentiation with respect to x of this term. Okay, this tells us that the equation is exact and we can move forward with the solution. Okay, next what we're gonna do, we have partial phi over partial x equals mu, as we said, which equals, as mentioned above, 2x y cubed minus 3y. Now we want to get the value of phi. In order to do that, you need to differentiate, to integrate this term with respect to dx. Doing that gives you x squared y cubed minus 3xy plus the integration factor g of y. Okay, then next what we're gonna do, we want to try to find the value of gy by differentiating the function of phi, which is nu. partial phi over partial y equals nu, which equals minus 3x plus 3x squared y squared minus 6y. So we said partial mu over partial y should equal partial nu over partial x in order to have an exact equation. And we confirmed here that this equation is exact. So we want to use that information to find the g of y. The moment we find g of y, then in that case we identified the function phi of x, and we have by that moment the solution for this equation. Okay, with that being said, now let's equalize the partial mu over partial y to the partial nu over partial x with what we got. So we can say 3x squared y squared minus 3x plus g y prime. So as we said, we differentiated the function of phi, and we got this equals minus 3x plus 3x squared y squared minus 6y. So these two terms should be equal to each other. From this we can conclude that g prime of y equals minus 6y. From that we can say that g of y, doing the integration, will give you minus 3y squared. Now, since we have the gy, we can plug it back in the official equation for the function of phi. So in this case, phi of x and y equals x squared y cubed minus 3xy minus 3xy minus 3y squared plus c. And this is the grand solution for our exact problem.